I would like to welcome Kyla Wood from Applied Polymer Systems. She'll be presenting this workshop today. All right, it is 10 o'clock. Kyla, I'll go ahead and hand the presentation over to you.
All right, thanks, Gabby. So I'm really excited. This is my second Stormwater Awareness Week. I want to thank John and Gabby for letting me be a part of this again. It's a really great platform to learn about stormwater technologies, and also for us who want to kind of share our message or share our technologies. And so today, what we're going to be talking about is passive treatment. So the use of flocculants like polyacrylamides to manage stormwater turbidity. So although this technology is used, nationwide and also internationally, we're really going to focus today on California. And that's because we're about 1 year, I think almost exactly 1 year since this technology has been available for construction stormwater use. And so I know that this event now has gone, not just nationally, but internationally. If you're not in California, it doesn't mean that, some of this information might, not be useful. There's still a lot of passive treatment information that you could still use regardless of where you are in the country. But you'll learn, quite a bit about what we're doing in California right now. So what we're going to do today is I'm going to introduce passive treatment. We'll talk about what the technology is, why we use it, how it works. And then I want to focus on, some of the things that we've learned and maybe needed to clarify or, kind of change direction on that we've been working on specifically in California in the past year since it's been, this technology has been adopted. We'll look at some of the specific rules and regulations that maybe you want to emphasize or expand on. And then I also compiled some frequently asked questions that we tended to get over and over again over the past year as we started to, introduce and use this technology in California. So with that, I'll do a real brief introduction about myself. My company, my name's Kyla. I'm Chief Science Officer at Applied Polymer Systems. I've been in the Applied Polymer Systems specializes in passive treatment. We're a family-owned and operated company. I've been kind of working in this since I was in, middle school, so I was born into this. I did step away from APS for a while, and my background is in aquatic toxicology. So a lot of the work and research that I did before coming back to APS involved using different types of chemical treatment to manage harmful and toxic algae. And so really, my training is in the use of chemical treatments to find better ways to safely and effectively manage water quality. So APS, we were born in the mining industry in Southeast
Can't hear
Alaska.
shit.
Oh, hello? Okay. I hope everybody can hear me. So again, we started in the mining industry. We didn't invent passive treatment, but we were the first ones to introduce it into the southeastern United States in the mid-90s. And since then, the technology has really expanded, become very broadly used across the United States and also globally. So we're very focused on quality. Most of us at APS are scientists, so we focus a lot on safety of products, high quality drinking water grade, and we're going to talk a lot about some of that as we move through passive treatment technologies today. So with that, let's go ahead and get on to talking about passive treatment. So I want to start with a timeline of where we started and kind of where we are at in California. So passive treatment is not new. As I mentioned before, it was introduced in the 1990s to the erosion and sediment control and stormwater industries. We started out in Georgia, and it's expanded from there. It moved and became so widely used and adopted that it was first addressed in the federal construction general permit in 2012. Chemical treatment was first addressed and different, rules surrounding its use. California, although the permit allowed passive treatment just last year, it has been used in California before that in sites that aren't regulated by the CGP. So it's been used for water treatment on landfills and things like that. In 2021, there was a research study from the Office of Water Programs at Sacramento State. They did a very robust and extensive research on chemical passive treatment to provide guidance to the state of California. And that helped feed into the adoption of passive treatment in the 2022 CGP. And as I mentioned, this has been live for about a year now. And where we're at currently is this past year, we've really been learning to use the new tools and focusing on the rules surrounding the use and getting trained up to use these technologies. Now, with any new technologies, there's certain things that we have to overcome before it's fully adopted. One of the biggest things is education and training. So we want to learn about these new tools, how to use them. In California specifically, they're one of the only states in the country that requires that you get trained on passive treatment before you use it. So that's been a big thing that we've focused on in the first year. Also making sure we're following the rules and regulations in the CGP. Now, the rules and regulations in California are not necessarily that different than those across the rest of the country. They're just much more structured, and there's a lot more documentation that goes with them. And so we'll talk about that a little bit as we go. And then, of course, adoption and implementation. So passive treatment, I like to say, it's not rocket science, but it's still science. And so there are some fundamentals of understanding how flocculation and passive treatment works that we need to understand to really get it to work well in the field. And so that's something we've also been working on. And of course, the benefits of having new technologies is that now we have new tools where we have some more cost-effective ways to manage, some of our turbidity issues that we may have had trouble meeting in the past. So with that, let's go ahead and jump into what passive treatment is. So passive treatment, as we're defining it, is the use of chemicals to passively remove contaminants from stormwater via flocculation or coagulation. I'll explain that a little bit more in a minute. What I do want to say is, again, we've got potentially an international audience today and also potentially people from all over the country. So passive treatment can have some different definitions depending on maybe what industry you're in or what region. So if you're in the mining industry, you might hear the term passive treatment and envision constructed wetlands or promoting bacterial treatment of effluents and things like that. Or if you're in the southeastern United States, if someone tells you that you're doing passive treatment, they're going to assume it's gravity stormwater flows. If you use a pump to move water, they might say, oh, well, that's actually, semi-active. So today, what we're calling passive treatment and the way it's defined in California is we're using chemicals to remove contaminants from stormwater in gravity flows and pumped flows. So that's the definition that we're going to be using for passive treatment as we go through today. And again, what type of contaminants are we targeting with passive treatment? Primarily, we are after sediment and turbidity, and that's what's called out specifically in the California CGP. But the flocculants that we'll be talking about, we'll get into in a minute, also are able to remove metals, some nutrients, and of course, sediment's a great transporter of other pollutants. So if we have any sediment-bound pollutants, we're able to remove that sediment, we can remove those as well. So why do we need passive treatment? We have a lot of traditional, physical BMPs that can be very effective at helping us manage contaminants and turbidity in our stormwater. However, when we have very small particles like clays, silts, and metals, those can be too small for us to remove through physical settling or filtering. Even a silt fence, the pore sizes in a silt fence, if you have clay, silt, or even fine sand, those can move through the pore sizes of most silt fence. So what we can do to enhance those BMPs so that we don't have, impacts from sediments in our receiving systems is that we can enhance those existing BMPs using chemical treatments. And that's what passive treatment is. We're using chemicals to remove turbidity from water. Now, the material that we're going to be talking about today is called polyacrylamide, or PAM, and specifically anionic polyacrylamide. That's the chemical that's primarily called out in the CGP in California, and PAM is also the most widely used passive treatment chemical in the United States as well, and also many other areas of the world. So why do we specifically use polyacrylamide for passive treatment? Why is it mentioned in the 2022 CGP? Well, the first and most important is that it's a really safe material. So the anionic polyacrylamide specifically has a very low toxicity, so it's safe for sensitive aquatic organisms. This is really important for passive treatment because we are doing treatment systems. These aren't highly controlled. They're out in the open environment, and we want to make sure that if there are any accidental discharges or movement of that material, out of our treatment area, that it's not going to cause any harm. So it's really important that we have a low toxicity, safe material. So that's the number one reason. Safety is, not all that we need. Obviously, we're not going to use something if it doesn't work. The other benefit of PAM is that it's also very effective at taking out those things that we're after, like sediment and metals. So the polymer itself, it's this really long chained polymer molecule. It has a lot of different charge points on it, can bind a lot of sediment at once. And you can see in this picture, create little particles into really big particles. So now our BMPs, like our sediment basins or our silt fence, can capture those and settle them. And lastly, there's over almost a century of use and research with polyacrylamides for drinking water, agriculture, erosion control. There's lots and lots of research. We know a lot about the material. We have a lot of information on that safety and effectiveness. So again, that's why we're going to focus on PAM, and that's why it's so widely used. There's a few different forms of PAM that we use depending on what type of application that we're doing. So as you go through, you'll see some pictures, and we'll talk about a few different things. And so the polymer itself, it looks like a white granular. And so the granular form of the polymer is what it looks like when it's made. And that is used for both, water treatment and also erosion control and soil stabilization. We then take that granular form and we hydrate it into a solid log, like you can see in the right side of the picture there. And those dissolve slowly in flowing water and designed specifically for passive treatment. So we're applying it to flowing water to remove turbidity. And then we have the liquid emulsions. So liquid emulsions are concentrated liquid solutions of the PAM. Those specifically are usually not used for water treatment. They're not allowed to be used for water treatment in California. And that's primarily because they use some different surfactants and emulsifying agents to make those solutions, and those have some associated toxicities. You can still use those for terrestrial applications like erosion control and dust control, but you're not going to apply them to water. So the two things that we'll primarily be talking about moving forward for passive treatment, water treatment, is going to be the granular material and the flock log material. So benefits of passive treatment is, again, we're able to remove some of those different contaminants, but it's also a much lower cost, less power, less infrastructure, and typically less maintenance than active treatment systems. Both have benefits. Active treatment systems can, get to a really low turbidity. They're very well controlled. Passive treatment systems, again, we're not relying on computers, pumps. We're not doing residual testing. We are typically using existing BMPs that are out on our site and enhancing them with these flocculants. So a lot less infrastructure and typically a lot less cost associated with passive treatment. Some of the other benefits of passive treatment is we're using a little bit of material, really goes a long way. So a small dose of this can do a lot of work in terms of turbidity removal. If we use the flock log forms, it releases a relatively steady dose. So there's no injection system or manual inputs. Safe for aquatic organisms. It's safe and easy to handle. It's a drinking water grade polymer. It works in a wide range of temperatures. And one of the things that makes it really beneficial for passive treatment is that PAM specifically can also be used in a really wide range of pH. So if we look at some chemicals that are used in active treatment, they might only work in a small pH range, so it takes pH adjustments and things like that. You don't have to do that in passive treatment with PAM. And then it's also not going to change the pH, where something like aluminum sulfate for water treatment, we might drop the pH. PAMs near neutral in solution. So those are some of the other reasons why we use it for passive treatment. Now, today, again, as I mentioned, I really wanted to focus on some of the pieces that have been have come up the most in the past year for California. So I'm not doing my traditional presentation where we go through a bunch of BMP examples and things like that. If anybody watching this is interested in, looking at examples and case studies and a little more application heavy, certainly reach out. We've got lots of training material and presentations that we'd be happy to discuss that. But I did, just before we jumped into some of the, fundamentals and the rules and regulations, I just wanted to show a couple examples, if you're not, familiar with passive treatment, what that might look like. So in these pictures here, a lot of times we're taking our, our flock logs or a granular polymer, and we're applying it to existing conveyances. So you can see the logs in this channelized flow. We apply those to check structures. So if we've got rock checks or wattles or things like that, we'll apply the polymer to those. So a lot of times using existing infrastructure, sometimes we build, you'll see a lot of natural fiber mattings. That's great for collecting flocculated particles. You'll see that in a lot of our treatment systems. And then other passive treatment would also be putting these in pumps. So that could be a closed system. In this top picture here, you can see these kind of sock-looking things that are blue. Those are actually flocculant logs in kind of a sausage link configuration that get input into that Y clean out in that pipe. We also put them in drains. So these are all still passive treatment, a little bit different. Sometimes we use tanks. Doesn't mean we can't use tanks for passive treatment, but what this is we'll either put it in a hose or a pipe leading into the tank and use the tank for settling. Or in this bottom picture here, there's actually a bunch of flock logs in that pipe that goes around the top. So just in your mind, these are all different things, examples of passive treatment. So there's a lot of different ways to use this technology under that umbrella of passive treatment. So the first thing that I always start with, if you've ever seen any of my presentations, I always include the fundamentals. This is one of the most important things as we get trained up and learn and start to use passive treatment and PAM technologies, is that an understanding of how it works is going to help us use it effectively in the field. And there's some very specific rules that we need to follow where if something's not working, 95% of the time it goes back to one of these fundamentals. So I'm not going to spend a ton of time on them today, but I just want to make sure that we're on the same page with these before we go into some of the California specific rules and questions that we've had coming up. So how the PAM works is it has to be in flowing water. It's kind of a two-step process. You kind of think of this ball of yarn. We put it in the water, it unwinds, and once that polymer chain is unwound, then we need mixing and reaction for it to bind to those sediment particles. And it's kind of like a snowball effect. So we need mixing, flowing, turbulent water so that polymer can physically attached to the particles in the water. We take little particles and turn them into bigger particles. So eventually they're heavy enough to settle out or collect in one of our sediment controls. So, and then typically what we're aiming for with these is, we'll look at the formulations, but usually when we're accurately or effectively using a passive treatment technology, we're usually aiming for turbidities in the 20 to 30 or less range after using the flocculant. So the 5 fundamentals for effective flocculation are formulation, and we'll go through these in a minute. So we're going to match the correct PAM to the site soil and water, and this is a requirement both federally and in California. We're going to make sure we're using the right amount, not too much, not too little. If we don't use enough, we're not going to have effective flocculation. We want to have enough mixing quality. We talked about that kind of snowball reaction. We got to make sure that we have mixing to create those flocks. And then we also have to have enough time to form those flocks, which is our reaction time. And then lastly, our particle collection. Our goal of passive treatment is to remove turbidity and contaminants from water. So if we take little contaminants, turn them into big contaminants and send them off our site, we're not really doing what we set out to do. So just a brief overview. So what we call the cup testing or jar testing is referred to as performance testing in the CGP. And what we're doing is anionic polyacrylamides. Within that class of chemical, there's a lot of different types. They might have different molecular weights, so they're different lengths, different sizes. They might have different charge densities, so how many binding sites are along that long polymer chain. And each one can change which soils and sediments it works on. If we don't do a performance test and match, we might have no reaction and have no effect. So we'll have free dissolved polymer in the water, and we've wasted our money and we haven't gotten any results. So the jar test or the performance test is pretty simple. We do it free of charge. We train people to do it and send out sample kits. And what we also learn in these tests is how long the reaction time takes, which is something we also need. So performance testing required and very, very important and worth the, extra day or so that it takes to do a performance test. Mixing and reaction, again, is also very, very important. Typically, we're looking for 15 to 60 seconds to fully complete our flocculation reaction and take our small particle and turn it into a big particle. We determine how long that reaction time is in our performance jar test. This can lead into, if we have a linear channel that we're using, how long does it need to be? If we have a 15-second reaction, that could be, 20 feet. If we've got minutes of reaction, that could be a couple 100-foot channel. So making sure we're picking a flocculant that's going to react quickly is important from a practical standpoint as well. If we don't have a lot of space, there's ways to adjust and get better mixing and reaction without increasing the length of a treatment area, just by adding check structures, wattles, baffles, bricks, rocks. Anything to increase turbulence and retention time is going to help with mixing and reaction. And lastly, application rate for passive treatment. Again, I said earlier that a little bit of PAM can go a long way for flocculation. So what we're usually targeting is about 2 to 5 milligrams per liter of polymer in the water. So that might look like a couple sand grains in about a quart of water. So we don't need a ton of material. Too much material doesn't make it work better. It can actually make it work worse. And so we want to use as little material as possible while achieving effective results in terms of our turbidity. So in a real world situation, what that looks like is about 25 pounds of polymer fully dissolved in about 1 million gallons of water. Now, in practical applications, when we're doing passive treatment, we're not always able to recirculate and fully dissolve, these floc logs in the water because they don't dissolve instantaneously. They usually last, at least a week, sometimes up to 3 or 4 weeks, depending on how much rain you get. So what we typically do is we'll dose the floc logs in a passive treatment system based on your flow rate. So rule of thumb, for anything less than 1,000 gallons per minute, you're going to use about 1 floc log for every 50 gallons per minute. So I know I'm kind of fast and furious through that. I'm happy to provide more information, but just wanted to make sure we go through those fundamentals, because that's one of the biggest things we see is if we're not understanding what we need to make the treatment system work well, and we miss one of those fundamentals, then we might be doing 80% of what we need to be doing, but we're not going to see results. So the fundamentals, we always want to go back to those and have a good grasp on what those are. So with that, and the last one that I had mentioned for flocculant fundamentals was particle capture or floc capture. Again, our goal is to keep those particulates on site. In California specifically, they don't say what type of sediment control you have to use, just that you have to capture that floc. There are some states that require you to use a basin. That's not necessarily the case in the rules and regulations in California, but we'll look in those in a minute. So we're usually using traditional BMPs. Fibrous matting works really well to collect flocculated particulate, has all these natural fibers, a lot of surface area. And so in that upper left-hand corner, you can see flocculated sediment attached to the fibers of that jute matting. So we can also use silt fence. So this is 2 rows of silt fence with straw in between. That can be used to collect flocculated particulate. We can use tanks, again, jute matting. We kind of strung those as particle curtains to collect extra flock. If you have really fine flock, that's always beneficial to get some additional particle collection. You can use traditional traps and basins to settle the flock. You can kind of create, this is a kind of a muscle wall. They filled this with plastic and made a temporary basin. Here on this project, they did velocity dissipation. We like to call that a dispersion field. So they discharge out of their treatment zone, run it over a widened area and with a lot of jute matting to collect the flock. So we can get pretty creative with how we capture the flocculated particulate. So with that, I want to go ahead and get
I gave
into
you stuff tonight, to stuff last night that was true.
get into some of the rules and regulations for California specifically. I'm not going to read all the rules and regulations to you. You can, of course, go in there and do that yourself. So the rules surrounding passive treatment and flocculant use in California is in the 2022 Construction General Permit. Specifically, the requirements for use of those passive treatment technologies is found in Attachment G. What I wanted to do today with those rules and regulations is kind of expand on some of them that I think are really important for either safety or effectiveness, and also ones that I've had quite a few questions on. So again, with passive treatment, per the permit language, this is just differentiating. We're using passive treatment without the use of computers, pumps. We're using it with existing BMPs. And so let's go ahead and look at some of those highlighted pieces out of the Attachment G. And so in the general requirements, the very first one that I wanted to discuss is that passive treatment cannot be used as a standalone best management practice. And this is really not a California specific rule. Most states that you see with flocculant guidance are going to say this exact same thing. And we really like to stress this because if you're not using proper erosion and sediment controls on your site, you can't, take a box of flock logs and throw them on your site and thinks that it's going to magically cure your sediment issues. So passive treatment is really, it works with the traditional BMPs that we're likely already using on our site. And so there's a couple different categories of BMPs that we really stress need to be used with the flocculants. So if we don't have any upstream erosion control or sediment control, and we have a lot of erosion and sediment, if that moves into our passive treatment area, we can bury our flocculant, we can bury our passive treatment zone. And so we still need to have, we want to treat that turbid water. If we have, liquid mud or high sediment coming in and burying our treatment zone, we're not going to have great results. So upstream erosion and sediment control is important. We talked in those flocculant fundamentals. There's also using other BMPs in our actual passive treatment zone. Again, check structures, natural fibrous mattings, those types of things are really going to enhance the way our passive treatment system works. And then, of course, particle capture is we're relying on sediment control BMPs to help us capture the particles at the end of our passive treatment zone, sediment basins, things like that. And so, I can't stress enough how important it is to use our other BMPs with our flocculant and our passive treatment applications. Another thing that we hear a lot is it shall be applied by a trained person. So this, again, California is one of the first states that requires training, and it doesn't explicitly state what type of training that is. What I've learned so far is that a lot of that training can come from a manufacturer. There will be a 2-hour passive treatment technologies workshop if TASCA, if anybody's going to that. Essentially, so the training, there's not necessarily a guideline for the training, but it is really important that you understand, what the chemicals are, what you're using, how much to use, how to make them work. So it is important, to get trained up, to effectively use this technology. And then lastly, in California, it's important that you have to document your passive treatment in a plan and actually write that and submit it to the state. And so this is something that has been a big change for us since the adoption of the permit last year, is that we never really planned to write passive treatment plans. We had just planned to provide dosage calculations, toxicity information, the how to set it up for different sites, so application information. And what we've come to do over the past year is that we've started writing the majority of the information that's needed in a plan, just because to come from us. So one thing that's really changed from this year is that we're now providing the passive treatment plan documents, because it just makes sense for us, because we have that information. So that's something that's changed quite a bit, and something that's required in California. I think they're the only one in the country that right now that requires that kind of robust plan. But the information in the plan is really not that much different than what we would typically, provide to other people around the country. It's just in a more structured format. So again, going back to attachment G, some of the other really important pieces, we talked a little bit about this earlier, but for some of the design requirements is that only anionic, which is negatively charged chemicals, are authorized for use. Now they call out PAM. There are other, negatively charged flocculants out there, but PAM is certainly the most widely used. Cationic materials with a positive charge typically carry a high toxicity to aquatic organisms, so they're not allowed. The reason for that is negatively charged chemicals will repel against the negative charges on fish and aquatic organisms' gills. And so they're, typically not harming fish and other aquatic organisms. Cationic polymers, they will bind very readily to the gills of aquatic organisms. And so a very small amount can cause toxicity. So cationic chemicals, they are allowed to be used in active treatment systems, because those systems are very controlled. They're filtering the residuals, they're testing the residuals, but they're just not allowed in passive treatment. Passive treatment, only anionic chemicals, particularly anionic PAM. The other thing that is important is that a licensed professional engineer shall design the discharge locations from the area that's treated with passive treatment. So this was something we've had a lot of questions on. I'm going to come back to this towards the end in the frequently asked questions, but that's something that is a requirement in California that's different than the rest of the country. And then lastly, one thing you'll see in attachment G is, we talked about this with our particle capture and collecting our flock after we've created it in our passive treatment zone. So once we treat the stormwater with PAM, we have to pass it through some sort of sediment control, BMP. And in attachment G, it says sediment basin or trap, which is great. And then it also calls out filters like sand filters or geotextile bags. I just wanted to make a note of that, is that I know people who use the sediment and dewatering bags, and they'll put the flocculants in the pipes that lead into the sediment bag. It seems like a really great way to capture flock. Every site that I have been on, I've seen those bags burst in like 15 to 20 minutes. So the flocculant can actually clog the inside of the bag, and then they basically rupture in a very short period of time. So I would just point out that, that's something that you'll probably run into. And I would suggest, if you have to use a sediment bag, I know sometimes that's required in some projects, then you want to use your flocculant downstream of that sediment bag. Other requirements, we have toxicology requirements for the chemicals that we're using. So if you look at attachment G, you'll see that it has to be, food grade or drinking water grade. And the purpose behind that is really just to make sure that we have a high quality chemical. And so you can actually look up there's an NSF standard 60 certification, which needs to be found. That's how drinking water chemicals certification by a third-party organization. So you can Google NSF, look up standard 60, and actually Google companies, and it will tell you whether or not their products are certified. But what that's going to tell you is that there's not a lot of impurities in that product that's going to cause any issues. So, there's a lot of different sources, especially internationally, of PAMs. And some of them don't, they don't have the same process, and there might be some additional materials in there. So you want to make sure you're using high quality food grade materials. And so that's what that requirement there is for. The other thing that you'll see in the attachment G is you'll see a lot of information, or I'm sorry, requirements on what type of toxicity data you need, how that test is done, what species. But there's only, sorry for all the words on this, but that very last bullet, this is really the only piece in there that explains kind of what that toxicity information is for. And so it says that the toxicological information in the passive treatment plan shall indicate the safety of the passive treatment products based on the expected release rates, toxicity reports, anticipated concentration. So I just wanted to clarify kind of what that means and why the toxicity information is so important. So within the range of anionic polyacrylamides, there can be although, you're typically going to be on the same order of magnitude, there can be a big range in the toxicity just of those different forms of anionic PAM. And so if we look at kind of our happy blue fish down here, when we use an anionic PAM for passive treatment, we want to use an amount that, or we do, use an application rate that's going to be safe for aquatic organisms. What the toxicity studies tell us is every chemical, no matter what it is, water, medicine, if we use too much of a chemical, at some point it's going to reach a toxic amount. And so what our toxicity reports for PAM tell us, and the reason it's required we get these, and at least they're available for our passive treatment systems, it's going to tell us where we could start to see harm to aquatic organisms. And our goal in passive treatment, again, because we're out in the open environment, it's not a super controlled system, is we want to have as big a space as possible between our application rate and where we might start to see effects. And typically with PAM, the reason it's allowed for passive treatment is because there's a big margin of safety in there. But it can vary by product. And so it's really important that we have that information. That's why you see a lot of that listed in the permit. It's the same concept with medicine. So if I take some ibuprofen or some Advil, it's relatively safe. If I take way too much, I want to know where that space is, where my safety net is. And with PAM, we typically have a very, very high margin of safety. Another thing that you'll see is that in California, it's important to note that we are not allowed to apply passive treatment products directly into receiving waters. And we also have to have a barrier or a buffer zone between the discharge of our passive treatment zone and the receiving waters. So the reason I kind of want to emphasize this, because it kind of seems like a no-brainer, but if you get online and you Google floc logs or flocculant logs, you'll see multiple pictures like this where you see waters and flocculants in natural water bodies and streams and things like that. There are places in the country and there are industries that use anionic PAMs directly in water bodies for certain purposes, whether it be turbidity or nutrients. Just because it's done somewhere else does not mean it can be done in California. So just I guess word to the wise is that we're not allowed to be doing that per attachment G in California. So do not apply directly to water bodies. Passive treatment application requirements. A lot of the emphasis in there is on manufacturer guidance and making sure that people are trained. So again, we have anionic PAM primarily as the material that we're using, but depending on who the manufacturer is, we're not the only ones that make flocculant logs. They might be different sizes. They might have slightly different dissolution rates, different toxicities. So it's really important to follow the manufacturer guidance for the specific product that you have. If you do a performance test and write a passive treatment plan and plan an application, you may not switch that product to something else. So you have to, because they're not interchangeable, it's really important that you're following manufacturer's guidance. That's going to keep the application effective and safe and minimize any of that excess material from running off your site. Performance testing that we talked about, again, I think I already mentioned this, but it's also required. It's in attachment G. You have to do a performance test before you use a passive treatment product. And you're also going to follow that manufacturer guidance on how often it needs to be applied and reapplied, because our reapplication rate will depend on what type of polymer we're using. So if we apply a granular polymer, it dissolves a lot faster. It has all this surface area than something like the flock log. And so they'll have different, reapplication rates, and depending on how much rainfall you get. And so it's just important to make sure we're following those product specific and manufacturer specific rules. For the monitoring requirements, going to kind of breeze through this, but these are some of the other requirements that you'll see in attachment G, is that they want a list of the other erosion and sediment control BMPs that are used in the treatment zone. They want to have maintenance and removal procedures for the products that are applied on site. We include this in our passive treatment plans, and it will be available. Any manufacturer should be able to get you that information. There's inspection requirements for the treatment zone. There's going to be on your site map, you're going to call out where the treatment zone is, where the discharge is, the location of your particle capture buffer, if it's there, those types of things. Just, well documented what you're doing and what you're doing it with. For inspection, they do require a QSP to inspect the passive treatment zone 72 hours prior to a forecasted event, and also within 48 hours after a qualifying event. And so when we've talked about this, it's been kind of a grumbling point for a few people. But, regardless of where you are in the country, I would suggest to go and check your passive treatment before a big rain, no matter where you are, whether it's a requirement or not. You want to make sure that there's still product there, that it's enough, that it hasn't moved out of kind of the flow of where the water is going to be. So it's always, with any BMP, these might be relatively low maintenance, but they're not maintenance free. So any BMP has to be maintenanced in order to maintain its function and continue working properly. They also require that the passive treatment plan is submitted 14 days prior to passive treatment use. So again, that's kind of a California specific rule. There are some other states in the country that, require that you give written notice if you're using any sort of chemical treatment, even passive. And so it's not the only country, it's just kind of a different way of submitting that information. So with that, I just wanted to finish off with some of the frequently asked questions that I've gotten in the past year since this is rolled out, and then hopefully have a few minutes. I think there's a few questions in the chat, but I'll hopefully get to those as well. So one of the questions that we hear a lot is, if I apply, PAM for erosion control, one of the benefits of polyacrylamide, it's been used in agriculture for close to 70 years, is it controls erosion. And one of the other benefits, in addition to controlling erosion, it's also going to improve runoff water clarity in sheet flow. And so if I have applied a PAM for erosion control and it's helping clarify some of the non-channelized flows on my site, is this passive treatment now? Do I need a permit? And the answer to that is, in almost all cases, no, because there already are rules per the CGP and also in Caltrans that PAMs and have been used for erosion control in California for a long time. So these have a lot of their own rules and regulations, and they're not the same thing. So using flocculants for erosion control is not passive treatment. The second question, like I promised to come back to this one. This was one that I was unsure of and reached out and got some clarification from the water board. So what is the role of the PE? So if I go out and I do a passive treatment system, do I have to get a PE to basically redesign all my passive treatment zones? And so the answer to that question is, it depends. So if you are using an existing channel or an existing, BMP, if you're using, going into a sediment basin and those have already been designed by a PE, then you don't need to, reinvent the wheel and redesign those, and because it's already been done. So the goal of this rule was essentially that I'm not going to go out, build my own channel and have it discharge and start causing more problems with erosion. So there are some situations where we'll build kind of a standalone treatment system and pump water out, run it through, and then discharge. So my understanding is that if we were to do that, and one of the treatment plans that we drafted for a site in outside of Los Angeles was that we used a split pipe, pumped the water down, and kind of designed our sediment capture at the bottom. And that did need some additional engineering because we needed that discharge designed. Like a question we get a lot, how do I know how much to use? That's that manufacturer guidance. You want to make sure that typically they'll have application rates on the product label. So, lean on the manufacturer there, but also make sure you have your toxicity reports, because I want my application rate to be well below any sort of toxicity threshold. So use the manufacturer's guidance, but make sure they have their toxicity reports to back up the safety of their product. How do I know what to use? I think we've pretty much covered this today. And the biggest thing is that performance testing, drinking water grade polymers, performance tested for my site. There's a few different things that go into that, but the biggest one in terms of effectiveness is making sure that we have tested the product and it's going to work for your site's soil and water. Where do I get a passive treatment plan? Again, this was probably the biggest change for us since this rolled out last September, is that we originally did not plan to do the passive treatment plans, but it just kind of progressed into it, just made the most sense. Who can write a passive treatment plan? So a QSD needs to be writing the passive treatment plan. That's one of the requirements for that. And then what training is required and where do I get trained? So I think we covered this for the most part, and there really isn't a set of specific rules about what type of training, what needs to be covered, how long the training is. But in my experience, I would think a minimum of, 2 hours at least to get, well versed. And the more, the better. The best way to get really trained up with the flocculants is to really get your hands on them, especially when you start, messing with those fundamentals and how slight adjustments can kind of change the outcome of that treatment system. So, the training, we have a lot of virtual options available. As I mentioned, next month at Casca, there's going to be a 2-hour workshop. So there's a lot of different training. So if you have questions of maybe where, or when you can get that, feel free to reach out. And then where can I get the products? There's a couple manufacturers. Obviously, we're a manufacturer, and so we have some suppliers that we work with that we've been setting up over the past year in California, and then we manufacture the products in Georgia. And so kind of what's next? Again, get trained. If you want to start using or implementing some of these passive treatment technologies, the first step is to get trained. The next step is to, if you have a project and you kind of see how it could work, what we need, see how that looks, maybe you want to pull the trigger and do a passive treatment plan. And then, as I mentioned, implementing the passive treatment technology is going to be, the next step is using the things that we've learned in the training and getting that out there to help manage those turbidity issues. And then lastly, I did a workshop for Oklahoma last week, and at the end there was a comment of someone who was like, "Oh yeah, we got the product. I don't think they did a performance test, but followed the instructions, on the spec sheet and didn't really have a lot of results." And we never heard a word. So it's really important when you're first getting started to utilize the product support. If you have questions, if something's not working. So, kind of a last mention about APS is that we're like very involved. So if you need training, we have that. If you need help with design and planning, not just in California with passive treatment plans, but there's some other states now that are requiring, if you have certain types of soils, that you have flocculant plans in place before you can get your plans approved. And so we've been working with that in some of those other states. I do a lot of the permitting for different states that have maybe pre-approved flocculant lists. Again, we manufacture the product. We help with implementation and use. We'll do virtual site walkthroughs. We love pictures. Send us a picture, show us what's going on. We'll mark it up and show you where to put the materials. So, don't think that if you try something, it doesn't work, that it's just, we're here for, every step of the way, essentially, to make sure that you can get the effective results that we're used to seeing with this technology. And then lastly, I know we've really focused on passive treatment, but just a quick, we don't just do water treatment. We have polymer materials, so soil stabilization, vegetation establishment, dust control. You can also use this technology to manage other materials. So we do some industrial work with sediments and things of that nature. So we're not just water treatment. There's a lot of other things that we have available. So if you have any questions, please feel free to reach out. And with that, I think I've got about 10 minutes. So I can go through the chat and try to walk through some of these questions. And thank you guys again for joining me. All right, I'm going to look through here. All right, one of the questions is, what would be the ideal training certification requirement specific to passive treatment use? So again, I think I kind of answered that already, but there's really not a specific requirement for training. But I really think important things to cover is we'd spend more time on those flocculant fundamentals. We'd look at a lot of examples. We'd look at certainly some videos and look at how some small adjustments could change the results. We learn how to do performance testing. A lot of times we'll ask people to send it to us so we can do side by side when you're first starting. But a lot of times, especially in California and internationally, we send out sample kits and teach people to do it themselves, because it's really nice to have those kits on site. You can do it on a tailgate, and then you can quickly double check and make sure that site conditions haven't changed and that your formulation's right. So again, nothing really specific in terms of rules for training, but the more the better. I'm gonna keep going down here, having trouble scrolling. Is there an impact PAM from sunlight and heat? So that is if you, for water treatment, we're applying it and we're doing this kind of fast acting, and then we're settling and collecting those flocks. If you apply it to a soil surface that's in direct sunlight, it does eventually break down the PAM. I think the rate is about 10% per year. So there is some photolysis of PAM heat. You have to get really hot. You're not going to have any natural conditions. It's going to break down PAM. Typically, if the water's warmer, you can have faster reaction time. So sometimes that can be a benefit. Regulatory hurdles. Do we need to anticipate with the captured particles? That's a good question that I know of so far. I don't know of any thus far. What I have been hearing and typically suggesting for the captured flock is that in most cases, we want to reuse that. So say, for example, we're treating in a channel and we're capturing and settling that flock in a sediment basin. At some point, that sediment basin has a design life and a time that needs to be cleaned out. Maybe that's 50% capacity. So if we have flocculated sediment at the bottom of that, now we have a polymer treated sediment. A lot of times what we want to do is, if you have areas that are prone to erosion or that you want to establish vegetation on your site, we want to reuse on the same site. If we have jute matting that is saturated with flocculated sediment, we can pull that up and use that again. However, if that's not an option, the PAM is non-hazardous. There's no special disposal considerations. So, it could be hauled and you don't have any special way to dispose of that. Again, it's a drinking water chemical. It's non-hazardous. So I probably check into that more, but that I know of right now, there's nothing that I've heard of for that specifically. let's see. Are you aware of any permit violations issued in California over the past year? If so, what were the issues and how could they have been avoided? So far, I have not. I actually have not heard of too many passive treatment systems that have been implemented. Again, most of the questions we've done quite a few passive treatment plans. We've done a lot of training, but I think we're still ramping up to when we start using it. We've had a lot of people reach out recently now with the upcoming rainy season, so maybe that'll be a good question for next year. Is there a general rule for reapplication time for powder to unstabilized areas? Yes. So typically, this comes out of North Carolina State. I lean on them for this because they are big proponents of using powder applied to wattles and mattings and channels. And they would typically say to reapply the granular every half inch of rain. So what we like to say is I typically suggest and promote the use of the flock logs with the silt stop granular. And the reason for that is that the granular polymer, again, with all that surface area, can typically react quicker. And sometimes we can get to a lower turbidity using the granular compared to the flock logs. However, the flock logs are going to have a much longer lifespan. And so, so maybe if we happen to, I guess in California with our inspection requirements, we're much less likely to run out of the granular PAM, but we see that a lot in the other states as we throw it down once and then we never put it down again. It's like, it's not working. So if we use the flock logs with the granular, we get our kind of long lasting flocculant, and then we also have our short acting, highly reacting flocculant. So with that, I think we got one more question here. What would most of the concern with disposal be based on the sediment characteristics and not the PAM itself? That's a great question. If you have contaminated sediments, then yes, you would need to follow whatever the rules are for the contaminant that's in the sediment. No disposal considerations for the PAM, but yes, if you have contaminated sediments, you have to manage them in the appropriate manner for the contaminant that's in that sediment. So thank you for that. That's a good clarification.
All right. Well, thank you, Kyla, for presenting today. And I would like to thank everybody else for participating in Stormwater Awareness Week this week. That is it for our presentation this hour. There are still quite a few more today that you can go and sign up for if you haven't already. And this presentation will be uploaded. It has been recorded, so you can find it at stormwaterawareness.com. Within the next 24 hours, it should be posted for your review. All right. Thank you.
All right. Thank you. Thank you all so much.